In this video dealing with the concept of completing the square, we are going to look at a special example for it. We're going to take all the concepts we looked at so far and we're going to apply it to a more difficult problem. So here we go. We have the quadratic 2x squared minus 7x plus 5. Let's at least take some of our basic ideas we've learned before and apply them here. And the most basic idea was the quadratic and linear term need to be isolated. The constant needs to be moved to the other side. And so what I'm going to do is I'm going to subtract that 5. So I get 2x squared minus 7x equals negative 5. Now if you were to think about all the other examples we've done so far, this looks different at this point. And what looks different is you have a coefficient for your x squared, but all other examples we've done so far never had a coefficient that was not 1. This is unique. It's special. It's a little more difficult. And so what you need to keep in mind here is you cannot complete the square with a leading coefficient that is not equal to 1. That doesn't mean this problem is not possible. You cannot do it as is. So what you have to do is you have to create a leading coefficient equal to 1. The only way we are able to complete the square is if that leading coefficient is 1. So if it's not 1, you have to turn it into 1. That's the fun part about math, is if we can't work with an equation in the form that it's in, we can manipulate it into a form that we can use. And so the question I ask is, how do you turn a 2 into 1? And what I'm going to do is I am going to divide every term by the leading coefficient. You can't just do it to 1 because then that changes the value of the equation. But if I do it to all of them, then I can work with it as is. And so if I divide everything by 2, that gives me x squared. That gives me my leading coefficient of 1 minus 7 halves x equals negative 5 halves. And so now I have my quadratic, my linear term isolated. Now I have my leading coefficient of 1. And so therefore now I can complete the square. So I'm going to insert my placeholders, just like I've done before. So x squared minus 7 halves x plus my placeholder, whatever c value I find. And if I do it on the left side, I'm going to have to add it on the right side. So here comes the fun part. I am going to have to take half my linear term. My linear term is negative 7 halves. I'm going to take half of that number. Which remember, if you are taking half of that number, you're dividing by 2. And dividing by 2 is the same as multiplying by 1/2. And so that gives me negative 7 fourths. So half of negative 7 halves is negative 7 fourths. You are going to square that resulting number, and that gives you 49 sixteenths. That is your constant. You are going to put that on both sides of the equation. And now we finish the idea of completing the square. What number did I square to get that 49 sixteenths? I squared a negative 7 fourths. And so the binomial squared, I would have x, and I squared a negative 7 fourths, so I'd have x minus 7 fourths equals, and I'm going to have to do negative 5 halves plus 49 sixteenths. And if I did negative 5 halves plus 49 sixteenths, they'd have to have a common denominator of 16. So this would be negative 40 sixteenths plus 49 sixteenths, which gives me 9 sixteenths. To solve for x, you're going to have to take the square root of both sides. That gives me x minus 7 fourths equals, and remember plus or minus. With square root and fraction, you square root the top and you square root the bottom. So if I were to solve from here, you would add 7/4 to both sides. So you get a positive 7/4 plus or minus 3/4. So remember, this is technically two problems. One, where it's 7/4 plus 3/4, which is 10/4, which as always simplify is 5/2. And one where it's 7/4 minus 3/4, which is 4/4, which is 1. And so my answer is x equals 1 or 5/2. So this one's a little more difficult. It dealt with the idea of completing the square. However, we had to create our leading coefficient of 1. So this is a special example. It's a more difficult example. But the process, as soon as you create that leading coefficient of 1, is exactly the same. It's just now you're going to be dealing with fractions. So make sure when you're adding fractions, you have a common denominator. Make sure you check your work with your calculator on make sure you're adding them right. Make sure you're simplifying them right. Make sure when you take -7/2 divided by 2, we should know by the time you're in algebra 2 that dividing by 2 is the same as multiplying by 1/2. That allows me to get my C value. So this is a special example. It's unique. Make sure you're confident with it and you understand the only new concept with this is you cannot complete the square with a leading coefficient that's not 1. So you must create it first by dividing all the terms by the leading coefficient.